Okay guys, this is slightly different than what we did before. Instead of finding the total resistance and the total current, we're finding the voltage and the current through an individual resistor. So number one here, it says find the current and the voltage through R2. So that's this top one up here. What we're going to do, we do the exact same thing we did before. We find the total resistance and the total current, and then we do some more steps, and I'll show you those here. So,
it's unlocked.
It's unlocked.
Gabe, it's unlocked. I wasn't there that long.
Okay. So, how do we find, is this series or parallel, first of all? Series. So what do we do to find the total resistance?
Add
Them up. So it's going to be 5 plus 15 plus 22. What's that equal?
42.
42 ohms.
Get that ohms.
Okay.
OMG.
How do we find the current in this circuit?
V equals IR.
V equals IR, so we're going to have 33 volts as V equals I times 42 ohms. Divide that out, our total current is equaling what?
0.79
0.79.
amps.
0.79 amps. Alright, everybody okay with me so far?
Yeah.
Alright, now, what we know is that the current in a series circuit is the same everywhere. So the current through the 5 ohm one, current through the 15 ohm one, and the current through the 22 ohm one are all 0.79 amps. So this is one of our answers. So the current through R2 is 0.79 amps. Does that make sense, everybody? How do you think we're going to find the voltage in that one? V equals IR. So the only equation we really have for these is V equals IR. We do V equals IR to find our voltage. So this is going to be the voltage through resistor 2, so I'll call that V2. What current are we going to use? 0.79 amps. And what's the resistance are we going to use? 15.
11.8.
And what does that end up equaling?
11.85.
11.8 volts.
What?
I got 11.79 when I did it, but that's okay. Alright, any questions about what we did up here?
Why is the current only through 15? Like, why isn't it through 22?
The
Or
current,
is it?
the current is through all of them. So the current here is 0.79,
Okay.
current here is 0.79, current here is 0.79.
And you just told us to find it on R2.
R2.
That makes
So,
sense. Okay.
so guys, if we're finding the current through R3, we do it the same way, except we do 22 instead of 15.
True.
Makes sense.
Make sense?
Yeah.
Okay, we'll do the one in parallel here next. Everybody okay if I erase this?
Yep.
Guys, quiet. Okay. So, how do we find the total resistance in this one? 1 over thing, right? So we're going to do 1 over RT equals 1 over 24 plus 1 over 4 plus 1 over 23. 14, thank you guys. So, somebody tell me what RT equals.
6.39
6.39
ohms.
ohms. How do we find our total current? V equals IR. So can somebody tell me what that equals using V equals IR?
0.94
0.94.
amps.
amps.
So you do it the same way?
Still do it the same way. You guys are gonna be mad at me in 1 second here, but that's okay.
Cool.
Alright,
It's different.
so what's the voltage through each branch in parallel?
The same.
The same.
So you have to add a little bit.
Okay, so the voltage across each branch is 6 volts. Does that make sense to everybody? So what's the voltage across R3 then? 6 volts. So voltage across R3, so voltage 3 is 6 volts. How are we going to find the current across R3 then? V equals IR, so it's going to be 6 volts equals I times 24 ohms. You get I equals, what's 6 divided by 24? Out 0.25. So these are our answers. So in a current, or in a parallel circuit, the voltage stays the same through each branch, and it's just the total. In a series circuit, the current stays the same. That's something to, why don't you write that down at the top of your paper. Series, voltage stays the same. Or series current stays the same. Parallel, voltage stays the same. Ryan?
Do you even have to do the top part?
Yeah.
That's why I said you guys were going to be mad at me. We didn't have to do that.
Oh, then why did we?
The reason we did that is,
Just curious.
this is the only example where you're not going to have to do that.
Oh, okay.
Does that make sense?
Yep.
So you're normally going to have to do that unless you start out with something in parallel, then you don't have to.
Okay, okay.
Wait, what is
And it doesn't hurt you anyway.
what is this 6V?
6 volts, that's just the voltage of the battery. What? Okay. Any other questions on this one?
No.
Alright, you guys good?
Yeah. Let's go.
Alright, now we're going to do a combination one.
I'm just here if you want it. Yes.
Alright, so we have series and parallel here. So again, the first thing we're going to do is find the total resistance. Don't write anything down yet, because I want you to write it down in the format I have it, because it will help you when you go back to find the current and the voltage here at the next one. So wait until I finish here, see what I did, and then I'll give you guys a minute to write it down. Alright, so the first thing I'm going to write down is the resistor we're looking for. R2 equals 20 ohms. Now to solve this, what are we going to do to find, what's the next step essentially to solve the total resistance?
Find the resistance of the parallel circuit.
Find those two in parallel, so R23. So R23 is going to be 1 over 20 plus 1 over 10. Somebody do that in the calculator for me? What is it, Kyle?
No, it's not. It's 0.15.
Alright,
6.66.
6.67.
67, yeah.
That makes sense to everybody?
These are
Anybody have any problems doing like the parallel branches? Okay. So now, how do we find RT?
Add that.
Add that one to 17.
6.67 to 17, so that's 23.67 ohms. Okay. So now, how do we find the total current in the circuit? V equals IR. I'm going to put that right here, and it'll make sense shortly. So what's our voltage?
30.
We have 30 volts equals I times our total current, our total resistance, I'm sorry, 23.67 ohms. Everybody know what those 3 dots mean, right?
Therefore.
Therefore.
Peter's talking about.
So we've got IT equals what?
1.25 1.27.
1.27 amps. Alright, everybody okay with finding IT there?
Yes.
Okay, now we need to find the voltage drop across R2 and 3. So the voltage is going to drop across this one, and the voltage is going to drop across this one. What are they going to add up to? 30. So we need to find the voltage drop across this whole thing, and we're going to use R23 to do that. So we're going to use the current we just found, the current that's flowing through this one, which is 1.27 amps, because this is these two are in series, and then we're going to use that and the resistance of this whole thing to figure out the voltage drop across that whole thing. Does that make sense what we're going to be doing?
No, but I'm sure.
Okay, I'll try to explain. I'll do it and then we'll explain it again if necessary. So we've got voltage across 2,3 equals 1.27 amps, which is the current going through that whole thing. That's the current going through both branches, times the resistance of 2,3, which is 6.67 ohms. What do we get when we multiply those two together?
8.47.
Okay, so that 8.47 volts is how much the voltage drops from here to here. Does everybody understand that?
Yeah.
And the reason we were able to do that is the current flowing through this whole thing, so the current flowing through both branches, if you added them together, is 1.27. So we have the current through the whole thing, we have the resistance of the whole thing, then we find the voltage of the whole thing. Does that make sense what we did there? And-
How does the current for the entire thing? Oh, never mind. Is it parallel?
Yeah.
Or it's series?
So
The current is
Yeah.
the same in series. Okay, that's
these two are in series, so the current's the same through both.
okay.
Any other questions?
Is that it? That's how you do it?
We got one more step.
Oh,
But does everybody understand this step?
Yeah.
Okay. Now, what happens to the voltage in parallel? Is it the same or different?
Same.
Same. So the voltage to the top branch is 8.47, and the voltage to the bottom branch is 8.47. So in parallel, the voltage in each branch is the same as the voltage drop across the whole thing. So this is one of our answers. So the voltage through R2 is 8.47 volts. Everybody understand that? Okay, so now we need to find the current through that one. So how are we going to find the current through that one if we have the voltage? V equals IR, so we're going to do 8.47 for our voltage equals I, and that's the current in 2 times
20.
20 ohms. Therefore, I2 equals
0.42.
0.42. Alright. Everybody kind of see how that one works.
Yeah, I got the end.
Alright, let me kind of explain how I set this up and why I did it. So I started with one we were looking for. Then I went to the next combination with that one in it. Then the next combination, which was the total. What I did then is I used the battery and that to find the current. Then every other step, I did this and this to find this. Then I did this and this to find this. So does that make sense how that works? And if I made this more complicated, there'd be more steps here, but it would be the same thing. I'd take the resistance above and whatever I found below to find the next part. And you see how this alternates between I found current, then I found voltage, then I found current. That pattern always holds true. So it's always going to go current voltage, current voltage, current voltage. Does that kind of make sense what's going to be going on?
yeah.
Alright, we're going to skip number 4 and you guys are going to do that one on your own later.
Hold on.
Alright. Can I erase the circuit diagram anyway?
Yeah.
And we're going to go on to number 6 so you guys can turn your sheet over. Right. Can I erase it now? Or are people still copying? You good?
Yeah.
Okay. So first thing, is this in series or parallel with these two? This whole thing up here. Series. Because it has to go through that one. It has to go through both of those in some way, shape, or form. So they're in series. Does that make sense, everybody?
Yeah.
Okay. So we're looking for it in R2. I'm going to start with that one again. So R2 equals 14 ohms. What's our next step going to be?
Find a parallel.
Find R12. Does that everybody understand why we're doing that next?
Yeah.
We're going to find R12. And since we're just adding those together, what's that equal? 26 ohms. Now what's the next step? 1, 2, 3. So I'm just going to say R1 through 3. That's going to be 1 over 26 plus 1 over 10. Why don't you guys try solving that one? Right. 7.22 ohms. And what's the last thing we're going to do? Whole thing, so RT. And they're in series, so it's going to be this one 7.22 plus the 11 from this one. It's going to be 18.22 ohms. Questions on any of that so far? How do we find the current in the whole circuit? V equals IR. So what's our voltage? 24 volts. We're looking for IT. And what's our resistance? 18.22 ohms. So what does IT equal? 1.32 amps. Everybody okay with that one? Okay, so now what we need to find is the voltage drop across the R123. So we're going to use V equals IR, and we're going to use the resistance of that whole thing, along with the current we just found, because the current through that whole thing is 1.32, the current through this one is 1.32 as well. Everybody understand that? So we've got V, 1 through 3, equals 1.32 amps, and what's the resistance for that going to be? 7.22 ohms. And what does that one end up equaling? 9.53? I got 9.51. Close enough. And that's voltage. Any questions on how I got that? So our next step, we have the voltage across both branches of this parallel circuit is 9.51 volts. So we need to find the current to the top branch where R2 is. So how are we going to do that?
9.51 equals
We're going to call that I of 1, 2 times, what's the resistance going to be across that whole top branch? 26. Everybody understand why that's 26 and not 14? Okay. Alright, so what's I12 equal? 0.37? Okay. Questions on that one?
Why is it 26 and not 14? Like, I understand we're supposed to use what was across from it, but.
Because we're looking for the voltage across this whole, or the current through this whole top branch, and both those are in that top branch. Make sense?
Yeah.
Alright, now our last step, we have the current through both of these is 0.37. So current through R1 is 0.37, the current through R2 is 0.37. So how do we find the voltage drop across R2? V equals IR. We have V across 2 equals 0.37 times 14 ohms. So V across 2 equals
5.18.
5.12. Very close enough. Alright,
Yeah.
and what are our answers? 5.12 and 0.37. So 5.12 is the voltage drop across R2, and 0.37 is the current through R2. It's also the current through R1, but it's both. And we're gonna do one more together, guys, and then I'll have you do the other 3 on your own. We're gonna do number 7 together. We're not doing number 8 together, sorry guys.
It's okay, we can do it tomorrow.
Yeah, during your group quiz tomorrow.
Oh, what?
I heard it was first
Really?
Chondo Monday.
Actually,
I'm excited if we have a group quiz tomorrow. I'm not gonna lie.
Okay,
I'm just being serious.
We'll get you more peanut butter.
the group quiz is just gonna be over the stuff we've done the past 2 days though, okay?
Okay.
you better pay attention.
Brandon's got this.
I've been paying attention.
And I just redrew this a little differently, just so it's like it, all the other ones look.
You too, brother.
Close out.
What number are
This is number 7.
Thank you.
That'd be nice. Okay.
That's an ugly voltage line or a circuit at the bottom there.
Mr. Tente.
All he did
It's
was
okay,
move
we'll
it.
forgive you.
He's better than you.
You're not the last person to need it. So,
Have you eaten the whole bunch? Told you.
Sean knows.
Shut. He doesn't want it.
Alright. So, steps are still the same here, but when you're writing the stuff down on the other side, we only write the combinations that R4, the one we're looking for, is part of. Does that kind of make sense? So when we combine R1 and 2, we're not going to write that over on the thing over there because R4 is not part of that. Does that make sense to everybody?
Sure.
So we'll do that one first. So how do we find R12? Series or parallel?
Hello.
Hello.
Parallel. And when they're the same, does anybody remember what the total resistance is?
It's
Half. So if you have 2 identical resistors in parallel, the equivalent resistor is just half of that. So it's going to be 13 ohms for R12. That makes sense, everybody? Alright, so now I'm going to start by writing R4 equals 12 ohms. What's our next step to solve the total resistance?
R4 and R5.
R4, 5. And it's going to be 1 over 9 plus 1 over 12. And then take the reciprocal of that. Somebody tell me what that one equals?
5.14.
5.14.
What?
Yeah.
Now I got.
Try again.
I'm much nicer on video, aren't I? Normally when Kyle said that, I would have made some like smart aleck remark.
I miss your drawing.
Yeah.
Here you go, Mike.
You need to do that. Can someone like be stuck in there as a zit?
Yeah, I haven't died in a while, Mr.
Kyle.
Alright, there we go. So the 8 ohm resistor is actually Michael in the circuit. Okay.
But it's gonna be
I'm the only Michael.
Okay. Everybody okay with R45 now?
The power.
Yeah.
Anyway.
Okay. What's the next thing, what's the next resistance we're gonna calculate? Total? And our total resistance is going to be this one plus Michael's resistance here, which is 8 ohms, plus R12. Everybody understand that? So what do we get for that one?
26.14. Ohms.
Ohms. Right. Now how do we find the current in the circuit? V equals IR. So we've got 42 volts equals I total times 26.14 ohms. And our total current is what?
1.61.
1.61?
What did the 26.14 come from?
The 26.41?
Yeah.
That's this combination plus this 8 ohm one plus this combination that's 13
That's
ohms.
all of them. Okay.
Sorry.
Decide whether whether the current's the same or the voltage is the same when you're like moving up steps. Does that depend on which R you're on?
It depends on which R you're on. But the one thing that always happens this way, as you move up, the current, this step is the same, then the voltage is going to be the same, and the current's going to be the same, because you're always flipping back and forth between parallel and series. Alright, so what are we looking for next?
The voltage across 4.5.
The voltage across 4.5 is what we're looking for next. Does that make sense, everybody? So we're looking for the voltage drop from here to here. So we're going to use the total current in the circuit and the resistance of 4.5 to find that. So V45 equals 1.61 amps times 5.14 ohms. And what's the voltage across 4 and 5? 8.28 volts. So that's one of our answers. That's the voltage through that one, and the voltage through the bottom is both 8.28. Last step, we need to find the current through R4. So we gotta use the voltage across R4, which is 8.28, and its resistance to find the current. So we do 8.28 volts equals I4 times 12 ohms. And what's the current through 4?
Is it 0.92?
Should be 0.69.
Okay, what is it?
Alright, any questions on that one? Sarah?
Why did we do 1, 2?
Why do we do 1, 2 over here? We want to keep the ones we do over in this column right here. We want to make sure that R4 is part of those. Since we're looking for R4, anything that R4 is in, we got to do over here. Anything that R4 is not part of, like these two, we're going to do off to the side. Because we're not going to use this when we go back in through the find everything through R4.
Just need to show that, you know that.
You just need, you want to write this down somewhere
Oh, because you added it.
because you added in over there anyway. Alright, any other questions? Okay, why don't you guys start with number 5. Try doing that one on your own. I'll put the answers out. And I'll come around and help you as necessary. And we're going to have a group quiz over these kind of problems tomorrow, so it'll be in your groups of 4 people here.
We take care.